Okay, lesson 5 and 6 I'm going to do together. So we're going to talk about statements. Okay, a conditional statement is an if-then statement. For example, if it is raining outside, then we will practice indoors. Okay, that is a conditional statement. If something, then something will happen. So in notation, you would write it like if P, then Q, like that. The hypothesis is the assumption. So in the above condition, the hypothesis is it is raining. And the conclusion is the result of the hypothesis. So in this, the conclusion is we will practice outdoors. Okay, converse is a conditional statement in which the hypothesis and conclusion are switched. So the example here would be if we practice indoors, then it is raining outside. So we switch them around. So the notation would be if P, then Q. A biconditional is a conditional statement whose converse is also true. So logically, you would say it P if and only Q. So the notation would be a double arrow. Okay, an example would be if a number is even, then it is divisible by 2. That is true. And if we write the converse, it also has to be true. So if a number is divisible by 2, then it is even. Okay, so biconditionals, condition and converse have to be true. Counterexample is when you use an example that disproves a statement. So for example, this statement, it is Monday, then it is a school day. So I can disprove that so it's false because you could say that it's Thanksgiving Monday. So on that Monday, nope, we don't have school. Or you could state that a summer Monday, right? Inverse is a statement that is formed by negating both the hypothesis and the conclusion. So for example, write the inverse of if a number is even, then it is divisible by 2. So the inverse would be if a number is not even, then it is not divisible by 2. So we added nots in front of the statements. And then the contrapositive is when you do both an inverse and a converse at the same time. So you're going to switch the hypothesis and conclusion and negate them. So if I did this one, same example, so then you would say if a number is not divisible by 2, then it is not even. Okay, and last thing is learning to do a truth table. Okay, so given your hypothesis is true and that your conclusion is true, you would state if P, then Q is also true. If you switch it around, this would also be true. True, given true. Then when you see this symbol, it means not P. So not P would be false, not Q would be false. Okay? I'm going to talk to you about the only way to get a false statement. Is if you state something is true and conclude that it's false. That's the only way to get a false statement. Okay? So if we do not P, not Q, false, false is actually true. And false, false is actually true. Okay, so I'm going to write the not, the negated ones. So this would be false, true, true, false. And then these would be both true. Okay, so where do we end up seeing a true given false? Would be right here, P, Q. So that one would be false. And this one, if you go from not Q to not P, is false. Not Q to not P, so this one would be false. And then here would be false, so not P to not Q would also be false. Okay? So this is true and true. True, and this one is another false because Q to P is true to false. Okay, and I think that's the only spots we see. So on a truth table, this is important to know, this is the only situation you can get a false if you're given a true hypothesis with a false conclusion.